Hello students, today I am going to discuss thermodynamic chemistry related work calculation. What is work? We know work equal to force into displacement. Now force, this is F, displacement, now this is dx. Now we know force equal to, now pressure, suppose pressure equal to force by area. Now force equal to pressure into area, all over we know. So this is pressure into area into dx. Now this is P external pressure, this is external pressure, P external into dA dx into A, this is called dV, this is volume unit. Area into displacement, this is volume unit, so this is dV. Now a gas kept in a container or a cylinder, kept in a cylinder through a piston. This is the gas, this is internal pressure, P internal pressure, and outside this pressure, P external pressure. Now find initially P external equal to P internal pressure. Now after sometimes if P internal pressure greater than P external pressure, so gas expand because P internal pressure is high than the P external pressure, so gas expand. So volume change, this volume V initial volume, and after this volume V final volume. So V final greater than V initial volume. There is P internal pressure and here is this is P external pressure. Now P internal pressure is higher than the P external pressure, so this is gas expand. So volume increase, gas expansion. But sometimes if internal pressure less than external pressure, suppose P internal pressure less than P external pressure higher than the P internal pressure, so gas compression is there. So P external pressure and P internal pressure, so volume decrease, this is volume V final dot. So V final dot less than, this is V initial, so initial volume greater than the final volume, so gas is compressed, gas compression. So P external pressure and volume are inversely proportional because in P external pressure lower but volume higher. So there is the work equal to this is P external into dV, so dW equal to P external into dV. Pressure increase, P external pressure increase, volume decrease, or P external pressure decrease, volume increase. So there are reverse, so this is the negative sign. So dW equal to P external into dV. This is most important equation. Now total work W equal to dW integration equal to minus P external into dV. This is another most important equation. So W equal to minus P external pressure into dV. This is most important equation. So remember this thing. This equation is most important. Work equal to for gas is expansion. For expansion condition work equal to negative value, or work done by the system, this is also negative. But in case of compression work equal to positive, and work done on the system is positive. So remember this thing, work equal to minus P external dV. If the gas is expansion, so this is negative work, this work is negative sign, and work done by the system, this is negative, and compression condition, so this is positive, and work done on the system, this is positive. Now in case of reversible condition, reversible isothermal ideal gas expansion condition, reversible isothermal ideal gas expansion condition work calculation. Work equal to, we know this is P external pressure into dV. For reversible process, P external not equal to constant. P external not constant. So in case of ideal gas, we know PV equal to nRT, ideal gas equation. So P equal to nRT by V. Substitute this value. This is P external. Suppose this is P external. So this is nRT by V into dV. So nRT into dV by V. T, this is constant because this is called isothermal process. We know isothermal process T equal to constant. This is all the constant part. So constant part outside the integration. So this is nRT. This is, we know, dx by x. This is integration. This is ln x. So dv by v integration. So this is in limit v1 to, suppose this is v1 to v2. So this is ln v. Sorry, this is ln v. This is v1 to v2. So this is nRT ln v2 minus ln v1. So this is minus nRT ln v2 by v1. So this is the equation. So work equal to minus nRT ln v2 by v1. So this is most important equation. For reversible isothermal expansion for ideal gas equation, W equal to work equal to minus nRT ln v2 by v1. V2 means final pressure, final volume by initial volume. So this is nRT ln v final by v initial. This work is most important. Now reversible isothermal expansion for van der Waals gas. Now van der Waals gas equation, we know P plus n square A by V square V minus NB equal to nRT. This is van der Waals gas equation. Now P equal to P plus n square A by V square equal to nRT by V minus NB. P equal to nRT by V minus NB minus n square A by V square. This is the pressure unit. Now we know work calculation equal to minus P external pressure into dV. Suppose this is V1 to V2 limit. In case of reversible process, P external not equal to constant. So suppose this P external, this is, suppose this is P external pressure. So this is V1 to V2. So put this value nRT V minus NV minus n square A by V square into dV. So this is V1 to V2 nRT V minus NV dV minus plus V1 to V2 n square A by V square into dV. So this is nRT, T constant. So outside the integration part, because this is isothermal process, so T constant. So this is dV by V minus NV V1 to V2 plus V1 to V2 and n square A, this is constant part, n square A outside this integration part. So V to the power minus 2 into dV. So this is nRT ln V2 minus NB by V1 minus NB plus n square A into, this is 1 by minus 1 by V. This is V1 to V2 limit. So this is nRT ln V2 minus NB by V1 minus NB plus n square A 1 by V1 minus 1 by V2. So work. This is the most important work calculation for reversible isothermal expansion for van der Waals gas equation. This is most important equation. Work equal to minus nRT ln V2 minus NB by V1 minus NB plus n square A 1 by V1 minus 1 by V2. Irreversible isothermal expansion for ideal gas. Work calculation. For irreversible isothermal expansion, two condition is there. First, P external pressure equal to 0 and P external pressure equal to constant. P external pressure 0, that means in vacuum state or free expansion. This is called free expansion. And P external pressure equal to constant. First discuss P external pressure equal to 0. So work calculation. We know work equal to minus P external into dV. minus P external pressure into dV. So P external pressure equal to 0. So this is 0 into dV. So total this is 0. So work equal to 0 for irreversible isothermal expansion, but for vacuum or free expansion condition work equal to 0. But irreversible isothermal expansion, the P external pressure equal to constant, so work equal to, we know this is P external into dV. So this is V initial to V final. So P external pressure constant, so outside the integration part, so P external outside, so V initial to V final into dV. We know dx integration, this is x, so P external, this is V limit V initial to V final. So this is P external V final minus V initial. So this is the work for irreversible isothermal expansion for an ideal gas. Ideal gas, in case of ideal gas, we know PV equal to nRT. Now suppose P external replaced to P2, work equal to minus P2. Suppose V final, this is V2 minus V initial, suppose this is V1. So this is the work. Now in case of ideal gas equation, PV equal to nRT, suppose this is P1, V1 equal to nRT, and P2, V2 equal to nRT. T because there is isothermal condition, so T are constant. So work equal to minus P2, V2 minus V1, P2 minus V1. So P2, V2 means, in case of V2 means nRT by P2. So put this value nRT by P2 minus, similarly V1 equal to nRT by P1, nRT by P1. Now put this value nRT minus nRT, P2 by P1 minus P2 by P1. Multiplied this. So this is nRT 1 minus P2 by P1. So this is another most important equation for ideal gas irreversible isothermal expansion. Sorry, this is P2. So this is the most important, work equal to minus nRT 1 minus P2 by P1 for ideal gas in irreversible isothermal expansion condition. Question number 1. This question is most important. The diagram shows a PV graph of a thermodynamic behavior of an ideal gas. Find out from the following graph work done in the process A to B, B to C, C to D, and D to A. And second, work done in the complete cycle A, B, C, D, A. This is A to B, B to C, C to D, and D to A. Now the pressure 10 to the power 5 Newton meter to the power minus 2. There is 2, 4, 6, 8, 10, 12, and volume, this is liter. So this is 1, 2, 3, 4, 5, 6. This is 1, this is 6. And this is initial pressure 2 and final pressure 12. Now calculate this. First work calculate in case of work A to B. Work first A to B. In A to B, this is the work, this is the graph A to B. The pressure equal to constant but volume change. We know work equal to minus P external into dV. Now pressure equal to constant. So this is pressure equal to 12. There is 12 pressure into 10 to the power 5 Newton into meter to the power minus 2. And dV, there is V2 minus V1. So this is 12 into 10 to the power 5 9 Newton into meter to the power minus 2. V2 means this is final volume, this is 6, minus initial volume, this is 1. This is 1, this is 6. So 1. This is volume unit liter. We know 1 meter cube equal to 1000 liter. So 1 liter equal to 10 to the power minus 3 meter cube. So put this value. So this is 12 into 10 to the power 5 Newton into meter to the power minus 2 into, this is 5 into, this is 10 to the power minus 3 meter cube. So this is 60 into 10 to the power 2 Newton into meter. So this is the 6000 joule. Newton into meter equal to joule. So first calculate work A to B. Second calculate work B to C. So this is the cycle B to C, but there is volume is equal to constant. this is the cycle volume equal to constant. So we know work P external into dV. So volume constant, so this is 0 because volume equal to constant, dV equal to 0. So this is P external into 0 equal to 0. So work B to C, there is 0. Now third, work in case of C to D. Here is the graph C to D. There is also about the pressure equal to constant, pressure constant, but volume change similar. So here is P external pressure into dV. But pressure in this time and D, this is the pressure, this is the 2, this is the 2 pressure. So this is 2 into V2 minus V1, and here is 2 into, there is 2 into 10 to the power 5 Newton meter to the power minus 2, and V2 means 6, this is 6, sorry, this is V2 means final volume, this is 1, this is 1 minus 6 liter equal to minus 2 into 10 to the power 5 Newton meter to the power minus 2 into minus 5 into 10 to the power minus 3 meter cube. Liter change to meter cube. So this is 10 into 100 Newton into meter. So this is 1000 joule. Now work in D to C, D to A, last D to A. So this is the work, this is the graph D to A. This is volume constant but pressure change, volume constant. So this is the work W D to A minus P external pressure into dV, dV equal to 0. So there is 0. Now total work W A to B plus W B to C plus W C to D plus W D to A. Total work, this is cycle A to B to C to D to A. This is the cycle. So total work, this is work is minus 600 joule plus this is 0 plus C to D, this is 100 joule plus this is 0. So this is total work, cycle work. So this is minus 500 joule. So this is W A to B to C to D to A. This is cycle work. So this question is most important question. The second question, 10 mole of an ideal gas expand isothermally and reversibly from a pressure of 10 atm to 2 atm at 300 Kelvin. Calculate work in kilojoule. Now we know first this is ideal gas equation, ideal gas, and this condition is isothermal condition and reversible, and also this is expand. So this is expansion. So this gas equation, expansion, reversible, isothermal, ideal gas, we know work equal to minus nRT ln V2 by V1. This is the equation. First I calculate. So this ideal gas, we know PV equal to nRT, ideal gas equation. So this is isothermal condition, temperature equal to constant. So PV equal to R equal to constant, N also constant. So this is overall constant. So P1 V1 equal to P2 V2. So P1 by P2 equal to V2 by V1. So put this value V2 by V1. So work equal to minus nRT ln P1 by P2. This is another equation. Now the question, the pressure is given, pressure, initial pressure, this is P1 equal to 10 atm and P2 equal to 2 atm is there, and temperature T equal to 300 Kelvin and N equal to, this is number of mole, this is 10 mole. Now calculate this. Work equal to minus nRT ln P2 by P1, put this value, N equal to 10 mole and R, this is 8.314 joule mole inverse Kelvin inverse, and T, this is 300 Kelvin into ln P2, this is the value, P2 means 2 by 10 atm. This P1 equal to 10, and P2 equal to 2. So this is atm by atm, cut this value, and Kelvin, mole. So this is the value minus 4142.6 joule. So this kilojoule, 1 joule equal to 10 to the power minus 3 kilojoule, all over you know. So this is 40.14 kilojoule. So this is the answer. 1 mole of an ideal gas expands against a constant external pressure of 1 atm from the volume of 10 decimeter cube to a volume of 30 decimeter cube. Calculate the work done by the gas in joules. Now, first, the gas is ideal gas. Read this: ideal gas and expand. This is expansion condition, and against constant external pressure. So P external pressure equal to constant. So P external pressure equal to constant means irreversible process. Now ideal gas expand against constant external pressure. So we know work calculation, work equal to minus P external into V2 minus V1. This is irreversible condition, all over we know. Now P external pressure is given. P external pressure is 1 atm. P external pressure equal to 1 atm. And volume V2 is 30 decimeter cube, and V1 equal to 10 decimeter cube. 10 decimeter cube. So work equal to minus 1 atm. This is 10. This is 30 minus 10 decimeter cube equal to minus 20 atm decimeter cube. But work done in joule. So we know 1 liter equal to 1 decimeter cube. So this is 20 atm into liter. So this is 20 atm into liter into 8.314 joule Kelvin inverse mole inverse by 0.0821 liter atm Kelvin inverse mole inverse. All over you know R by R. There's gas constant. This is ratio. So this is atm liter Kelvin inverse cut, mole inverse cut. So this value is minus 20 into 8.314 joule by 0.0821. So this is the value minus 2025 joule. So work equal to minus 2025 joule. So this is the most important question. I will discuss more important topic. So please stay with me and like, share, subscribe, comment. Thank you.